Today I'm going to present to you a slide regarding virtual desktop technology. First of all, I'll be going through regarding background scenario. The background scenario is my manager thinking of providing some virtual desktop to deal with the notebook failure issue. So my role in an IT department of a marketing company, which have been requested to write and present a proposal to my manager. So this is what the issue that they are facing. Global design and 6 branches in Southeast Asia. Estimated staff we have is 60 management staff, 60 accountants or auditor, 60 human resource, 360 sales marketing staff, 800 electronic designer, and lastly 400 mechanical designer. So all staff travel frequently within all branches in Southeast Asia. Often they have to show their design to the customers, and sometimes they need to do coding while they are traveling. Often staff complain about the lack of technology when the notebook fails, on average 10%. So we create dedicated GPU as the designs can be very complicated for the following, which is AutoCAD, Autodesk, Object ELX, Ultimate Designer, Ultimate Nexus, Ultimate DXP platform, and lastly Microsoft Visual Code. First of all, I'm going to talk about compute solution. So we'll be using storage visualization. A storage system is also known as storage array, disk array, or filer. In computer science, storage visualization is the process of presenting a logical view of the physical storage resource to a host computer system, which treats all storage media in the enterprise as a single pool of storage. Storage systems typically use special hardware and software along with disk drive in order to provide very fast and reliable storage for computing and data processing. Storage systems are complex and may be thought as a special purpose computer designed to provide storage capacity along with advanced data protection features. Storage system can provide either block access storage or file access storage. Block access is typically delivered over a fiber channel, ASCII, SAS, FICON, or other protocols, while in the meantime, file access is also provided using NFS or SMB protocols. So we'll be using block access storage. Block access storage which use this context that refer to abstraction separation of logical storage partition from physical storage so that it may be accessed without regard to physical storage or heterogeneous structure. This allows the administrator of the storage system to have a greater flexibility in how they manage storage for end user. In the next slide, we'll be explaining regarding block access. A continuous slides from the previous one. In storage visualization, a disk array is a disk storage system which contains multiple disk drives. It is differentiated from a disk enclosure in that an array has cache, memory, and advanced functionality like read and visualization. Simple disk array provide a logical to physical abstraction as they use RAID schemes to join multiple disks in a single array. RAID 5 consists of block level stripping with distributed parity. Unlike in RAID 4, parity information is distributed among the drive. It requires that all drives but one be present to operate. Upon failure of single drive, subsequent reads can be calculated from the distributed parity such that no data is lost. Block access is typically delivered over fiber channel, ASCII, SAS, FICON, or other protocol. File access is often provided using NFS or SMB protocols, which we'll explain later in the slides. Typically, these arrays are divided into categories. Firstly is network attached storage, in short called NAS arrays. Secondly is storage area network arrays, which is in short called SAN arrays. So under SAN arrays there's three: modular SAN arrays, monolithic SAN arrays, utility storage arrays. So we'll be touching on SAN disk array because we're going to use it in this proposal. So in SAN disk array are joined to a RAID, which made a lot of hard disks look and perform like one big storage device. Every storage device or even partition on that storage device has a logical unit number, in short called LUN, assigned to it. When a storage device receives a request to request to read or write data, it will access its access list to establish whether the node, identified by its LUN, is allowed to access the storage area, which is also identified by a LUN. In computer storage, a logical unit number, or LUN in short, is a number used to identify a logical unit, which is a device addressed by the SCSI protocol or storage area network protocol, which encapsulates SCSI such as fiber channel or iSCSI. Each on the SCSI bus is assigned a unique SCSI identification number or ID. Device may encompass multiple logical units which are addressed by logical unit number. Simply drive have just one logical unit number. More complex devices may have multiple logical unit number. So generally, SCSI target device, which can be called a physical unit, is often divided into smaller logical units. For example, a high-end disk subsystem may be a single SCSI device, but contain dozens of individual disk drives, each of which is a logical unit. Further, a RAID array may be a single SCSI device, but may contain many logical units, each of which is a virtual disk, a striped set or mirror set constructed from portion of real disk drive, the SCSI ID. In this case, identify the whole subsystem, and the second number, the logical unit number, in short LUN, identifies a disk device, real or virtual, within the subsystem. Next slide will be going through regarding network solution. Network solution. Most storage networks use the SCSI protocol for communication between servers and disk drive devices. A mapping layer to other protocols is used to form a network, like iSCSI, mapping of SCSI over TCP/IP, iSCSI extension for RDMA, or in bracket known as ISA, mapping of iSCSI over infinity band. Lastly, iSCSI RDMA protocol, SRP, another SCSI implementation of RDMA transports. Since we'll be using SAN for storage solution, which often have their own network and storage devices, which have to be bought, installed, and configured, this makes SAN inherently more expensive than NAS architecture. Distinct protocols were developed for SAN, such as fiber channel, iSCSI, and infinity band. Using iSCSI or FC fiber channel network to connect as a SAN, these type of devices are the most common available implemented form of virtualization. We'll be using Internet Small Computer System Interface, in short called iSCSI, as it is an Internet Protocol IP-based storage networking standard for linking data storage facilities and provide block-level access to storage devices by carrying SCSI command over a TCP/IP network. iSCSI used to facilitate data transfer over Internet and to manage storage over long distance. It can be used to transmit data over local area network LAN, wide area network WANs, or the Internet, and can enable location-independent data storage and retrieval. The protocol allows SCSI called initiator to send SCSI command CDBS to storage devices target on remote server. It is a storage area network SAN protocols allowing organization to consolidate storage into storage area while providing clients such as database and web server with the illusion of locally attached SCSI disks. It mainly competes with fiber channel, but unlike traditional fiber channel which usually requires dedicated cabling, iSCSI can be run over long distance using existing network infrastructure. Next slide, we'll be talking about ways of implementing. Ways of implementing in-band, also known as symmetric, virtualization devices actually sit in the data path between the host and storage. All I/O requests and their data pass through the devices. Hosts perform I/O to the visualization devices and never interact with the actual storage device. The virtualization device in turn perform I/O to the storage device, caching of data, statistics about data usage, replication services, data migration, and thin provisioning are, are all easily implemented in an in-band device. Another one is out of band, which is also known as asymmetric. Virtualization devices are sometimes called metadata servers. These devices only perform the metadata mapping function, which require additional software in the host that known to first request the location of the actual data. Therefore, an IO request from the host is intercepted before it leaves the host. A metadata lookup is requested from the metadata server. This may be through an interface other than the SAN, which returns the physical location of the data to the host. The information is then retrieved through an actual I/O request to the storage. Caching is not possible as the data never passes through the device. Because no read-write data has to travel through the virtualization solution itself, the argument is that out-of-bound solutions are more scalable than in-band solutions. Therefore, we'll be using out-of-band. The out-of-band architecture avoids in-band issues by placing metadata control outside the data transport path. Individual server, however, must have visualization software agent installed so that I/O requests can be redirected to the out-of-band appliance. Separating data and control path ensure that the virtualization appliance will not act as a bottleneck to data transport. Although, as with an although as with in-band methods, loss of the out-of-band appliance itself can be destructive. Redundant out-of-bound appliance with synchronized I/O control could be configured to avoid outrage and provide high availability. So in conclusion, compute solution will be using storage virtualization with proposing to use this area as storage solution, using board level for the virtualization layer in storage virtualization technique. We'll be using SAN, storage area network arrays. In SAN, these arrays are joined through a RAID, which makes a lot of hard disk look and perform like one big storage device. Every storage device or even partition on that storage device has a logical unit number LUN assigned to it. In computer storage, a logical unit number or LUN is a number used to identify a logical unit, which is a device addressed by SCSI storage or storage area network protocols that encapsulate SCSI such as iSCSI. Using SCSI protocol for communication between servers and disk drive devices, a mapping layer to other protocols is used to form a network such as iSCSI. Virtualization method will be using out-of-band solution. By virtualization storage, a system can be made more scalable because commodity hardware can be quickly snapped in and discovered by the virtual software system. These hardware resources can then be added to a virtual pool of storage that is available to the virtual system. This is driven one of the hardest trends in the storage industry, which is a scale-out approach in which hardware capacity can be added quickly in modular fashion. I have come to the end of the slides. Thank you for watching.